Section 10.3 Part 2 is going to wrap up our work with ellipses, and we're going to start by talking about a final terminology called a focus, or the plural foci, and then we're going to work on being able to rearrange an equation of an ellipse so that it's in standard form, and the process we'll use is completing the square. We're going to be completing the square in terms of both x and y, so it'll be a little more complicated than in the past when we've just had one variable. So first of all, let's get some general properties of the focus. So each focus, there's 2 points, 2 foci, that lie along the major axis. And they're equidistant from our center point. So these are 2 points that lie inside our ellipse. In the pictures below, it says 2 green points that you can see. Okay, and our second property is that the sum of the distances from each focus to any point on our ellipse is a constant. So the sum of those distances to any point is constant. So you can see below in the pictures if I have D1 and D2, where D1 is my distance from the focus on the left, D2 is my distance from the focus on the right. No matter where that red point is around my ellipse, if I add up those distances, it's going to be a constant number. It turns out it's actually 2a, which is the length of the major axis. Now, the third property is that the foci are located a distance of c away from the center, where c is given by c squared equal to a squared minus b squared. So we know a and b from our general form of our ellipse equation. If we subtract b squared from a squared, we get the value of c squared, and that'll tell us the distance to travel from the center in either direction. Now, if you want the derivation for where this formula comes from c, you can check page 744 of your textbook. It's actually a pretty slick proof, not too difficult to understand. So our first example asks us for the given conic to find the location of the foci and produce a graph. So I'm going to start by identifying what I know. Well, I know that the center is 2, 1 based on my h and k values. I also know that my a value is equal to 3 and my b value is equal to the square root of 5. And I'm getting those by taking the square root of the 2 denominator terms under x and y. Now, the missing information is c, so I'm going to use my formula, a squared minus b squared. That's what c squared is equal to. And I'm going to get 9 minus 5, which is equal to 4. So c squared is 4. That means that c is 2. So the distance to the foci from the center is 2. Get that graph out of there. All right. Using that information, I know that my foci are located, in this case, since A goes with X, it's horizontally oriented. I'm going to graph the center now. It's at 2, 1. I'm going to graph the major axis is a distance of 3 in either direction, horizontally. And the square root of 5 is approximately 2.2. So we're going to graph that up 2.2. Do your best you can to kind of estimate it. And down 2.2. So So there's our ellipse. Now we know that this is our major axis, the horizontal. So the foci, I'm going to take my center point, which has an x value of 2, and I'm going to add and subtract 2 from that to get my new x values. It still has the y value of 1, so I'm really taking h plus or minus c k. That's my general formula. And that's going to give me 4, 1, and 2 minus 2 will give me 0, 1. So there's where my foci are located. The first focus is 0, 1. The next focus is 4, 1. And we've produced an accurate graph. From an equation, it's pretty easy. From a collection of information, it's a little bit harder to piece everything together. So I think it helps if we can graph what we know. Here we're given 0, plus or minus 3 as the location of the foci. So I'm going to plot those 2 points, 0, positive 3, and 0, negative 3. So right away I can tell this is vertically oriented, since the foci are along the major axis, and the major axis must be vertical in this case. Okay, so I know that I also know something. My center is 0, 0, because that's right in the middle. Okay, based on where the focus above is located, it's a distance of 3 up or 3 down. So I know my c value is equal to 3. Okay. The last piece of information I'm going to need in order to put the equation together are a and b. So I've got a minor axis of length 8. So what that tells me is that 2b is equal to 8, which means that b is equal to 4. Okay, I'm going to use that information combined with c, and I get c squared equals a squared minus b squared. So if I square 3, it should be equal to a squared minus 4 squared, 9, equals a squared minus 16. And I get a squared is equal to 25. Taking the square root, I get a equals 5, and I can start to graph everything I know. So b is equal to 4. From my center, I'm going to go to the right 4, and I'm going to go to the left 4. A is equal to 5, so I'm going to go up 5 from my center, and I'm going to go down 5 from my center. And now I can graph my ellipse. So this looks a lot like a circle. It's stretched out just a very little bit vertically, but you can see our focus points lie along that major vertical axis in this case. Okay, and let's put it all together for an equation. The center is 0, 0, so I get x squared and y squared on the top. It's always equal to 1. And now, because it's vertically oriented, my a value squared goes with the y value, so I get 25 on the bottom here. And my b value goes with x, so if I square it, I get 16 on the bottom beneath x. So I've got the equation, and I've got the graph. Our next examples require a little bit of work with completing the square. So I'm given an equation. You can see I have x squared and y squared. I also have x and y terms. I also have a constant term. So I'm going to complete the square for both x and y, keeping track of everything that I add to the left side, and I'm going to do the same thing on the right side. So here we go. Let's put x squared plus 6x plus a blank. That's going to be our first completing the square. We're also adding 4y squared, but I'm going to factor out the 4, so I get 4 quantity y squared minus 2y plus a blank. So the 4 times the minus 2 gives me the minus 8y from above. And that's going to be equal to, I'm going to subtract the 9 to the other side, so I get minus 9 plus my first blank plus 4 times my second blank. Okay, so I'll do the work for x in red. We're going to take 6 divided by 2, and we're going to square it. That's 3 squared, which is 9. So I'm going to put a 9 in that first blank. Now for y, I'm going to take negative 2. I'm going to divide it by 2 and square it. I get negative 1 squared is positive 1. So I'm going to put a positive 1 in both of those blanks that go with y. I can now complete the square. So I have x plus 3 quantity squared plus 4 times the quantity y minus 1 squared. And that's equal to negative 9 plus 9. Those cancel out. And I'm left with just 4. Okay? Now you might think you're done at this point. We completed the square. However, an equation of ellipse has to be equal to 1. So what we're going to do is divide everything by 4. And our final answer is going to be x plus 3 quantity squared all over 4 plus y minus 1 quantity squared over 1, since our 4's cancel here. And that's equal to 1. Now from there, we're in standard form. We can identify vertex, major and minor axis, A and B, foci, etc. Okay? So we're going to do one more example of those, and then I'll send you on your way to try one on your own. So our last example, we're going to start by completing the square, and then we're going to graph our ellipse. So the x terms first, let's just write them. 4x squared minus 48x. And then we also have plus 9y squared plus 72y. And I'm going to set that equal to negative 144. So in red, I'll do the x term. So I've got 4 times the quantity x squared minus, if I factor out of 4, I get minus 12x plus a blank. And then in green, I'll put the y term. So I'm going to factor out a 9. And I get y squared plus 8y plus a blank. That's going to be equal to our original negative 144. That I need to add on 4 times that red blank, and I need to add on 9 times that green blank for x and y. So if we do the work here, divided by 2, negative 12 divided by 2, we're going to square that, and we get 36 in both spots. If we take 8 divided by 2 and square it, we get our new c value, which is 4 squared is 16. That goes in our blank. Let's do a little simplifying on the right-hand side. We get negative 144. 4 times 36 is positive 144. 9 times 16 is also positive 144. So overall, my right-hand side is equal to 144. And my left-hand side has all these perfect squares. So it's going to be 4 times the quantity x minus 6 squared plus 9 times the quantity y plus 4 squared. And last but not least, we're going to divide everything by 144 so that we set our equation equal to 1. So a little bit of reducing here is necessary. 4 over 144 is going to give us 1 over 36. So x minus 6 squared over 36 plus y plus 4 quantity squared over 16 is equal to 1. All right, there's our final equation. Now for the graph, let's identify what we need. So the center, hk, is 6, negative 4. Our a value is equal to 6. Our b value is equal to 4, based on the 36 and the 16. If we want to find c, let's go ahead and do that. So 36 minus 16, c would be equal to the square root of 36 minus 16, which is the square root of 20, which is 2 root 5. All right, let's start to graph what we know. So we know the center is 6, negative 4. 1, 2, 3, 4, 5, 6. Negative 4. Our a value is with x, so it's horizontally oriented. And we're going to count 6 to the left and right. So right on the y-axis. And then a distance over of 6 to the right. Now we're going to go up 4 and down 4 from our center point because of b. 2 times the square root of 5 is approximately 4.5, so we're going to estimate 1, 2, 3, 4.5 over is where our focus is going to be from that center along our major axis. And we can draw our graph. Now to graph it, we estimate what this value is. If I wanted to know the actual location of the foci, then I'm going to take my h value, which is 6, and I'm going to add and subtract 2 root 5, and it always has the y value of -4. So that's how I'd write it algebraically, but obviously graphically we can't put 2 root 5 exactly on our graph. Okay? All right. Your job now is to complete the square on this next equation. You're going to have to complete the square for x and y. Once you get your equation, identify everything we just identified, including the length of the major and minor axes, and then get a nice graph.